Good afternoon, everyone. I am Janardhan now, and now I am going to explain about the Canopy clustering algorithm, which is a fast pre-clustering technique used in data mining. This algorithm helps in efficiently handling large data sets by reducing computation before applying more complex clustering methods. Introduction to clustering. It is a unsupervised learning algorithm. Clustering identify patterns in data without predefined labels or categories. It is similarity groupings. Groups data points based on their inherent similarities and relationships. Real world analogies. It is also in real world. It is used in data mining and pattern recognition and image processing and segmentation, customer segmentation and targeting. The main challenge of this by the traditional algorithms like k-means become computationally expensive when processing large data sets requiring multiple iterations and distance calculations. It groups data based on similarity. So we need a faster approach. This leads to canopy clustering. What is canopy clustering? Fast and appropriate. Uses simple distance calculation group data to quickly group the data. And it has processing steps. Serves as a different filter before applying more computationally intense clustering methods. And it is dataset reduction, reducing the number of data points that needs processing by downstream algorithms. And the fourth one is overlapping clustering, creating canopies where points can belong to multiple groups simultaneously. So canopy clustering acts as a filter before applying algorithms like k-means. One key feature is it's that it creates overlapping clusterings, meaning a data point when belong to multiple groups. The key concepts of the canopy clustering is thresholds, where this algorithm uses two thresholds, where T1 is loose threshold. Points within this distance are considered nearby and added to leaves canopy set, where T2 tight threshold. Points with this distance are very close and added to tight canopy set while being marked as assigned. Where the important condition is that T1 must be greater than the T2. The working condition, if distance is less than T1, point is added to loose canopy. If a distance is less than T2, point is added to light canopy and marked as assigned. So T1 creates a broader group while T2 creates a more precise group. Multiple canopies allow a single data point to belong to several groups simultaneously, enabling more flexible clustering while significantly reducing computational overhead. The algorithm steps which was used in this, the steps initialize. Select an unassigned data point from the data set. We will select a unassigned data point. Create canopy. Establish a new canopy using the selected point as the center. Evaluate points. Calculate distance between the canopy center to all unassigned points. Classify. If the distance is less than T1, add to loose set, and if the distance is less than T2, add to the tight set and remove from the future processing. This reduces data set gradually. Continue all until all points have been processed and assigned. This was the algorithm steps which was included in the canopy clustering algorithm. And now we discuss understand about the institution where T1 nearby points like students in the same academic department where T2 very close points like students in same specific class section. The two threshold approach creates hierarchical grouping where T1 identifies broader neighborhoods while T2 captures more precise relationships. This dual layer filtering efficiently reduces the search space for subsequent clustering operations. This two-level grouping reduces the search space efficiently, where T1 gives broader grouping and T2 gives precise grouping. Data, the data set which was used in this canopy clustering was get from the created using skitlearn make blobs function for synthetic clustered data and the parameters which contain with data set contain 300 data points two features, four clustering centers, cluster standard deviation, and the random state 42 for reproducibility. This was the code where we get the data set from the blobs. Code gen data generation, dataset generation, where X is the data points contains the actual coordinate to data for clustering analysis, where Y is the true labels, actual clustering assignments used for validation. Generated data, the characteristics of the generated data sets, synthesized clustering data, mimicking real world patterns, controlled patterns, ensure reproducible results, visual 2D structure enables institute understanding, known ground truth facilitates algorithm validation. The Canopy function, which contains the data input dataset containing all data points, where T1 leaves threshold containing broader Canopy membership, where T2 contains tight threshold controlling precise assignment and marking. This was the function which was used for canopy clustering. Since canopy clustering is we do not use labels, the dataset is structured to real world patterns. The core logic of the core logic of the canopy clustering Euclidean distance formula measures proximity between canopy enter and each data point, where distance is clarified canopy center comma point, where distance is less than t1 point added to loose, where distance is less than t2 point added to tight, and marked as assigned preventing duplicate membership in subsequent canopies. Implementation outcome. The algorithm efficiently partitions overlapping canopies, which each data point assigned to at least one tight canopy, while potentially belong to multiple loose canopies. The structure enables downstream algorithms to focus only on relevant subsets. This will reducing computation. Advantages and limitations of this. Advantages of the it is very fast, works well for large data sets, and reduces computation for k-means. Whereas it has a limitation. Depends on only T1 and T2. Both depends on thresholds. Produce approximate clustering. Overlapping clusterings are possible. Applications. This Canopy clustering was used in big data clustering, effective pre-processing massive data sets before more complex analysis, improve reliance by grouping similar documents or use queries, and it was used in recommendation system, quickly identify user groups and with similar preferences for personalized suggestions. Canopy clustering efficient in data processing. It is best for user as a pre-processing step before other more precise clustering algorithms. First group roughly, then cluster precisely. If you compare with k-means, canopy clustering is fast, but approximate k-means is accurate but slower. So canopy is used before k-means. If you use real life example, shopping website use similar logic to group customers. Broad interest T1 where strong similarity is T2. Thank you. And I want to show the outcomes with these are the outcomes which were generated through the loops dataset. These are the first five data points. First 20 canopies of the dataset which contains loose points and tight points. Thank you.